Hey there. Ready for a deep dive into practical deep learning? I've got this stack of sources you gave me, and honestly, it's pretty fascinating. We've got parts of a book called Practical Deep Learning for Cloud, Mobile, and Edge, some real-world AI examples that are already blowing my mind,
It is amazing how this field has evolved.
and even like a little bit of a history lesson on how this whole field even came to be.
Yeah, what I find so fascinating is how it's not just academics working on this
All
anymore.
right.
We're seeing this shift to where anyone can kind of jump in and build these powerful AI models.
Exactly. It's like deep learning is breaking free from just the lab and getting out into the world.
Huh.
And speaking of building things, the book actually walks through creating, get this, a cat versus dog image classifier.
Oh, wow.
Yeah, I know it sounds kind of basic, but they go through the whole process, like from choosing the hardware to making it super accurate.
What's amazing is how accessible that whole process has become.
Right.
They even talk about using like free GPUs in Google Colab. Yeah. So you can literally play around with deep learning right in your browser.
That's incredible. Okay, so we're seeing how to build these systems, but where are they actually making a difference? The examples you sent cover so much. We're talking self-driving cars, AI art generation, and even AI that helps visually impaired people.
Yeah. And as we explore these applications, it's important to think about their impact.
Absolutely.
The sources really stress the need for responsible AI development,
Of course.
addressing things like bias in data sets and making sure the models are really robust.
Right. So let's unpack all of this. How is deep learning shaping the world around us? And what does it mean for all of us who are using it every single day? Let's start with this rise of practical deep learning. What caused this huge surge in interest and accessibility?
Well, one key factor is the amount of data we have now.
Oh, yeah, that makes sense.
Like think about ImageNet with its millions of labeled images or BDD 100K for autonomous driving.
Yeah,
There's a Waymo open data set. This data is basically fuel for the deep learning engine.
right. So it's like giving these AI models a huge playground to learn from.
Absolutely. But data is only part of it.
Okay, so what else?
Advancements in hardware, specifically GPUs, have been huge. GPUs are like the workhorses.
Okay.
They crunch through these massive calculations so fast.
So it's like having a supercharged engine making the AI learn way faster.
Exactly. And then there's the development of these user-friendly
Oh,
frameworks.
yeah. Like what?
Like TensorFlow and PyTorch.
Okay.
They give you the tools to build deep learning models without having to code everything from scratch.
So it's like having a prefab toolkit for building AI, making it easier for developers.
Right. And we can't forget about transfer learning.
Oh, right. You mentioned that earlier.
That's been a game changer. Developers can take a model that's already trained on tons of data
Uh-huh.
and then fine-tune it for a more specific task.
I see. So like if a model's learned to recognize millions of images, we can then specialize it, like to
Yeah,
identify different flowers.
precisely. It's like taking an already smart AI and giving it specialized knowledge.
Wow, so cool. Okay, we've got the data, the hardware, the frameworks.
hmm
But how do we actually build a deep learning system? What are the steps?
It's kind of like constructing a building.
Okay,
You need a solid foundation, the right materials, a blueprint to guide you.
I like that. So what's the foundation of a deep learning system?
The hardware. And it starts with knowing your needs.
Yeah.
Are you experimenting, or is it a complex project needing heavy computing power?
So like, do we need a small workshop or a huge factory?
Exactly. For simple stuff, you can use free cloud resources like Google Colab.
Yeah, where you can access GPUs in your browser.
Right. But for larger projects, you'll likely need to invest in those powerful GPUs.
Makes sense. So hardware sorted. What's next?
Choosing the right data set,
Mhm.
like selecting building materials.
Okay.
You need high-quality data that's relevant to your problem.
And we have so much data available now, right? You mentioned those massive data sets earlier.
It's incredible how much is out there. But it's not just quantity, it's quality and relevance.
Oh, right, of course.
If you're building, say, a facial recognition system and your data is mostly people with lighter skin tones, it might not work as well for those with darker skin tones.
Yeah, that's a big problem.
Absolutely, it raises ethical concerns. So we need to be mindful of biases in the data and make sure it's representative.
I see your point.
To address that, there are things like data augmentation,
Okay.
where you create variations of your data to make your model more robust, like showing it the same object from different angles and lighting.
Right, so we're helping it generalize better.
Precisely.
Okay, hardware, data. What else do we need?
The blueprint, that's where frameworks come in.
Okay.
They provide the structure for building and training your model. TensorFlow and PyTorch are popular choices.
And you mentioned Keras, which is like a simplified interface for TensorFlow.
Yeah, It's more user-friendly for beginners.
So, like using a visual editor to build a website, you don't need to know all the code.
Exactly. Keras makes building powerful models much easier.
Cool. So hardware, data, and framework. Now we're ready to start building the model.
Exactly. And for computer vision, convolutional neural networks, or CNNs, are the go-to.
I've heard of CNNs, but how do they actually work?
Imagine a detective at a crime scene.
Okay.
They look at the big picture, then focus on details. Fingerprints, footprints, to figure out what happened.
I see.
CNNs analyze images in layers, with each layer extracting features like edges and shapes.
So it's like breaking the image down into smaller bits of information
Yeah.
and then using that to figure out what's in the picture.
Exactly. This approach is what makes them so good for things like image classification and even generating realistic images.
Now, how does transfer learning fit in with building models using these CNNs?
Remember that student who's good at basic math and is ready for calculus?
Yeah.
Transfer learning takes a CNN that's learned general features from like millions of images,
Sure.
and then you fine-tune it for something more specific.
So like if we're training it to recognize different dog breeds, we don't have to start from scratch.
Exactly. You can use a model that already knows general dog features.
And then just train it on specific breeds.
Right.
That's amazing. So we've laid the groundwork. We've talked about the hardware, the data, the framework, the model itself. Now, let's shift to the real-world applications of this tech.
Yeah, the range of applications is incredible.
I'm excited to hear more about it.
We've touched on self-driving cars and AI assisting visually impaired individuals. Let's dive a bit deeper into specific examples.
Perfect. I want to see how this tech solves real-world problems.
Let's start with online shopping. You know how websites recommend similar items based on what you're viewing?
Oh, yeah, for sure.
That's deep learning.
Really?
It uses something called similarity search.
Okay.
Deep learning models find visually similar images. It's used in e-commerce, art, even design.
That's fascinating.
And there are apps that change how we interact with the world. Think Snapchat filters.
Oh, yeah. Those are super fun. How do those even work?
Real-time face detection and tracking. Frameworks like TensorFlow.js and MLKit make it happen. Our phones analyze video from the camera, detect faces, track their movements.
That's crazy.
Yeah, so those filters follow your every expression.
It's amazing how this tech is just integrated into our lives.
And there are applications that are making a real social impact.
Yeah, for sure.
Like Microsoft's Seeing AI app.
That one's incredible.
It uses deep learning to help visually impaired people navigate. It describes their surroundings, reads text, identifies objects, even recognizes faces.
That's truly amazing.
And then we have autonomous driving, which is pushing the boundaries of AI.
Yeah.
Self-driving cars use a combination of sensors, algorithms, and deep learning.
I've read about companies making huge progress in that area.
It's coming. Fully autonomous vehicles are still being developed, but deep learning is already part of driver assistance systems.
Right, like lane keeping and adaptive cruise control.
Exactly. Those features are making our roads safer.
Absolutely. Okay, we've seen how to build these systems, and we've explored some incredible applications. Now, I'm curious, how are these models actually put into action?
That's a great question.
Yeah.
And that's actually the focus of the next chapter, where we'll explore deploying deep learning models to the cloud, web browsers, even mobile devices.
All right, I can't wait to hear about it.
Welcome back. Last time we talked about the basics of building a deep learning system and even looked at some of the cool ways it's being used out in the world. Now let's get into fine-tuning those convolutional neural networks, the CNNs we talked about.
Oh, yeah. Those are pretty amazing. It's like we've built this awesome engine, and now we want to make it run as smoothly and powerfully as possible, right?
Exactly. And the book really emphasizes that the key here is experimentation. Think of it like, being a chef in the kitchen.
Okay.
You have your ingredients, your tools, the basic recipe. But the real magic happens when you start experimenting, playing with different flavors and techniques to get things just right.
I love that. So we need to experiment with our deep learning models to find that perfect recipe for accuracy.
Exactly. And there are some great tools out there to help us on this culinary adventure. First, got to make sure our data is prepped and ready to go.
Right, like those massive data sets you talked about before.
Yeah. Well, TensorFlow datasets helps a lot with that. It's like having a sous chef who preps all the ingredients, making that data loading process so much smoother.
Okay, so we have our ingredients prepped, but how do we make sure our model is learning effectively? There's so much data.
Well, that's where TensorBoard comes in. Think of it as a dashboard in your kitchen, giving you a real-time view of what's cooking, so to speak. You can visualize and analyze the training process, see how your model's doing, even see how it's making decisions.
So it's like we can peek inside the oven and see how each ingredient is affecting the final dish.
Exactly. You get these insights into your model, you can spot problems early and make adjustments as you go. And to take our experimentation to the next level, there's the what if tool.
Oh, what's that all about?
Imagine a spice rack where you can instantly try out different flavors without having to start from scratch.
That would be awesome.
Well, the what if tool lets you do just that. You can compare different models side by side, see how changing different settings affects the outcome, even tweak the whole model structure.
So we can adjust the recipe as we go and see how it changes the final dish.
Precisely. And if you want to go even deeper, you can use TF Explain. It lets you see what your model is focusing on when it makes predictions.
Wait, so we can actually see what the AI is looking at when it's making a decision.
Exactly. Say you're training a model to recognize different types of birds. TF Explain can show you heat maps highlighting the areas the model's focusing on, like the beak, wings, tail feathers.
Whoa. It's like seeing the AI's thought process.
It is, and this can be super helpful for finding hidden biases in your model. Like if you're training it to identify clothes and it keeps focusing on the background instead of the clothes, there might be a problem with your data.
So it's like the AI is picking up on the wrong cues.
Exactly. Now, when it comes to actually improving accuracy, the book suggests a really systematic approach.
Okay, what does that look like?
Start with a simple model,
Okay.
and then systematically tweak different parameters one at a time, seeing how they affect things. It's like fine-tuning the knobs and dials on your AI engine.
I see. So it's all about careful observation and experimentation, like a scientist in a lab.
Precisely. And there are so many things to play with, like the learning rate, the batch size, data augmentation techniques, even the number of layers in the network.
That sounds like a lot to keep track of.
It can be, but remember, there are tools to help. The book introduces AutoKeras, which is like having an AI assistant for finding the best model setup.
An AI assistant, tell me more.
It automatically searches for the best model structure and parameters for your specific problem. You just tell it what you're trying to do, and it takes care of the rest.
That's incredible. So it's like having a master chef who knows exactly which ingredients and techniques will work best.
Exactly. And there's also AutoAugment, which does the same thing for data augmentation.
Oh, wow. So like an AI sous chef who preps the ingredients perfectly.
Right. And then for even finer control over your model's settings, there's Keras Tuner, which is like a set of precision tools for fine-tuning every little detail.
So we have all these amazing tools to analyze and optimize our models. But training them can take a lot of time and power, right? Like those powerful computers you were talking about.
Yeah, that's a good point. And actually, the next chapter gets into boosting TensorFlow performance, making that training process as smooth and efficient as possible.
Okay, let's speed things up. How do we make our AI engines run faster?
Well, it all starts with understanding where the bottlenecks are in your system.
Bottlenecks.
Yeah, like in a car engine. If it's not running smoothly, you got to figure out which parts are causing the problem.
Right. So how do we find those bottlenecks in our deep learning system?
There are tools for that, like NVIDIA SMI for monitoring GPU usage.
Okay.
It's like a gauge on your dashboard showing how much power your engine is using.
So we can see if it's working hard or just idling.
Exactly. And for even deeper insights, there's TensorFlow Profiler, which works with TensorBoard.
Oh, yeah, that dashboard we talked about.
Right. It gives you a detailed breakdown of what's happening during training, like having a mechanic under the hood analyzing every part of the engine.
So we can see what's slowing us down and where we can improve.
Precisely. And once you've found those bottlenecks, the book has a whole checklist of things you can do to optimize things.
Okay, give me some highlights. What are some of the best ways to boost performance?
One simple thing is enabling GPU persistence.
Okay.
It's like giving your data a dedicated lane to flow smoothly to the GPU. No traffic jams.
So we're optimizing the data flow, making sure the engine's always fueled up and ready to go.
Exactly. Then there's TF.data.
What that?
It's TensorFlow's API for building efficient data pipelines.
Okay.
It's like having a well-organized supply chain, getting the right data to the right place at the right time.
So we're making the whole data process super smooth from loading to feeding it to the model.
Right. And within TF.data, they talk about caching data in memory,
Okay.
like keeping frequently used ingredients close at hand,
Oh, that makes sense.
and prefetching data.
What's that?
That's like having the next course ready before the guests have even finished the current one.
Wow, so we're anticipating the model's needs.
Exactly. Now, another powerful technique is parallel processing.
Okay,
It's like having multiple chefs working at the same time, speeding things up.
I like that. More chefs, faster cooking.
Right. They talk about how to use it to speed up data loading and transformation so the data pipeline keeps pace with the training.
It's like a team of sous chefs working in perfect harmony.
Yes. And then for the model itself, there's quantization.
Okay, that one sounds interesting.
Think of it like using smaller containers to store your ingredients. You save space without sacrificing too much flavor.
So we're making the model more compact.
In a way, yeah. Usually models use 32-bit numbers, which are super precise, but take up a lot of memory.
Okay.
Quantization uses smaller, less precise numbers.
Yeah.
It might slightly reduce the model's accuracy,
Uh-huh.
but the speed and memory savings can be huge, especially on devices like smartphones.
So we're optimizing the recipe for a smaller kitchen.
Exactly. And they also stress choosing the right hardware and software that work well together. Like you wouldn't try to bake a cake with a blowtorch, right?
Not if I want it to be edible.
Yeah.
So finding that balance between accuracy, speed, and the resources we have.
Right. They even talk about pruning the model.
Pruning, like a tree.
Yeah. You remove unnecessary connections, making it smaller and more efficient.
Oh, so we're decluttering the model's brain, getting rid of the thoughts that aren't helping.
Exactly. With all these techniques, you can really boost TensorFlow performance, making your models faster, leaner, and more powerful.
That's amazing.
Yeah.
It's like taking your AI from a slow crawl to a super sprint.
Mhm.
But how do we know if our optimized model is really doing well in the real world?
Well, that's where industry benchmarks come in. The book mentions Dawn Bench.
Okay.
It's like a racing track for deep learning models.
Racing track.
Yeah. You can compare different models and see how yours stacks up against the best out there.
So it's like a Formula One race for AI, where the fastest and most efficient models win.
Exactly. They also mention competition specifically for low-power devices, which is crucial for things like smartphones.
Right. Those little devices have to be super efficient.
Yeah, it's like a mini marathon, where the goal is to get the best performance with the least amount of energy.
It's awesome how the drive for efficiency is pushing AI innovation.
It is. So we've covered tons of techniques to boost performance, making models faster and more powerful. Now, are you ready to unleash these models out into the world?
I am. Let's do it.
All right, so we've built these amazing models, made them super efficient, and now it's time to set them free in the real world.
Yeah. Time to unleash the AI. So how do we actually deploy these models and put them to work?
Well, the book takes us through a bunch of different deployment strategies. It starts with, get this, building your own server.
Whoa, hold on. Building a server? That sounds pretty intense. Is that something only, like, serious developers should even attempt?
It might sound daunting, but they use Flask, which is a Python framework, to show how it's done. And honestly, it's more approachable than you might think.
Okay, so break it down for me.
It's like building a little home for your AI model on a server where it can hang out, receive requests from users, and send back its predictions.
Oh, I see. So it's like we're setting up a shop where people can come in, bring their data, and get insights from our AI.
Exactly. But just like with a real shop, you have to take care of everything. Managing the server, making sure it can handle lots of customers if it gets popular, and keeping everything secure.
So it's a DIY approach for those who like to tinker and have more control.
Right. But if you're not a server whiz, there are easier ways. The book then gets into managed platforms, which are like all-inclusive resorts for your AI
Oh,
models.
that sounds nice. Tell me more.
We're talking Google Cloud ML Engine, Amazon SageMaker, Microsoft Azure ML Code. They take care of all the infrastructure headaches, so you can just focus on deploying and managing your models.
It's like checking your AI into a luxury spa where everything is taken care of.
Precisely. No need to worry about servers, scaling, or security.
So it's like AI paradise.
Hmm.
But are there any catches?
Well, even in paradise, things can go wrong. The book talks about failure handling.
Okay, what's that?
Think of it like a backup generator in case the power goes out. Servers can crash, data centers can have problems, and you need to make sure your AI system can handle those unexpected hiccups.
So we need a plan B, just in case.
Exactly. You don't want your AI to freeze up when faced with a challenge.
Right. And what about performance? No one wants to wait forever for an AI to do its thing.
That's a great point. And the book dives into strategies for optimizing performance and reducing latency, especially for things that need to happen in real time.
Yeah, like if I'm asking my AI to identify a plant, I don't want to be waiting 5 minutes for an answer.
Exactly. And they introduce some helpful tools. There's Kubeflow, which helps manage these complex machine learning workflows, and Faring, which lets you build, train, and deploy models right from your Jupyter notebooks.
So it's like having a whole team of AI engineers behind the scenes, making sure everything runs smoothly.
Precisely. But let's shift gears a bit. What about running AI directly in web browsers?
Is that even possible? Can we really bring AI right into the browser?
It is, and that's the focus of Chapter 10, where they dive into JavaScript and TensorFlow.js.
JavaScript, the language of the web.
Hmm.
So we can have AI running without any servers involved.
Exactly. They show you how to use pre-trained models like image classifiers and object detectors to create these interactive web experiences that are just mind-blowing.
So instead of sending data to a server, everything happens right there in the browser instantly.
Yeah, they even talk about using your webcam feed for AI applications that can respond to live video.
Oh, wow. That opens up so many possibilities, like interactive games that respond to your movements or educational tools that give real-time feedback.
Exactly, and they showcase some cool examples. There's PoseNet, which can detect human poses in real time using your webcam.
That's incredible. We could build apps that help you improve your yoga poses or even a virtual personal trainer.
The possibilities are endless. And what about generating art and creative content?
Yeah, can we do that in the browser too?
Absolutely. They even talk about GANs, those generative adversarial networks.
I've heard of those. Aren't those what make those deep fakes where you can make anyone say or do anything?
Well, GANs can be used for that, but they also have lots of creative applications like generating art, enhancing low-resolution images, even creating fashion design.
Okay, that's way more interesting. Like a website that lets you generate custom artwork or an app that lets you try on virtual clothes, all powered by AI in the browser.
Exactly. Now, let's talk about bringing this AI magic to our phones and tablets.
Yeah, what about mobile devices? Can we run these models on them?
Absolutely. They dedicate 2 whole chapters to mobile development. It starts with iOS and Core ML.
Oh, Core ML. That's Apple's framework for integrating machine learning into iPhone and iPad apps, right? So we can build AI-powered apps that run directly on those devices.
Precisely. They walk you through converting models from other frameworks like TensorFlow into Core ML format so you can use your existing models on iOS devices.
So even if we trained our model using TensorFlow, we can still bring it to life on an iPhone.
Exactly, and they cover ways to optimize those models to run smoothly and efficiently on mobile because nobody wants an app that drains their battery in 5 minutes.
Right. Performance is super important on mobile. But what about Android? Can we deploy our models to Android devices too?
Of course, they cover Android development using TensorFlow Lite, which is Google's framework for deploying to mobile and those smaller embedded devices.
So it's a lighter version of TensorFlow made for those devices with less power.
Exactly. They show you how to convert your TensorFlow models to TensorFlow Lite and then integrate them into Android apps. They also talk about Google's ML Kit, which has a bunch of ready-to-use tools for things like image labeling and text recognition, all powered by TensorFlow Lite.
So we have this whole library of AI building blocks that we can just plug and play with.
It's pretty amazing. And they even cover how to test different versions of your model using Firebase, which is Google's platform for mobile development. It's like having a focus group for your AI where you can see which version performs best.
Wow. So we can bring the power of deep learning to basically any device. But the book doesn't stop there, right? What else is there to explore?
Well, they go even further into things like object detection, where the AI can find and label multiple objects in an image, and image segmentation, where it outlines the exact boundaries of each object, like a digital artist.
Whoa, it's like the AI is becoming an art expert.
And of course, they talk about self-driving cars.
Okay, that's the ultimate AI challenge. How do they even tackle that?
While building a full-fledged self-driving car is super complicated, they actually give you a guide to building one in a virtual environment.
A virtual self-driving car.
Yeah. Using Keras and a game engine called AirSim, you can simulate a self-driving car and experiment with different algorithms and driving strategies without, risking any real-world crashes.
That's incredible.
Yeah.
So we can try out our self-driving car dreams in a safe virtual world.
Exactly. And they talk about all the challenges of bringing this to the real world, like collecting the right data, handling different weather conditions, and making sure the AI can deal with unexpected obstacles.
Yeah, a car that's only been trained on sunny California roads is going to have a bad time in a Boston snowstorm.
Exactly. And then they get into reinforcement learning, which is a whole other fascinating area of AI where the system learns by trial and error, getting rewards for good decisions.
So it's like training a pet, rewarding it when it does something right.
Pretty much. They even talk about AWS Deep Racer, which is a tiny self-driving race car you can actually train and race against others.
No way. That's so cool. I want one.
And finally, they wrap up with a whole chapter of resources and answers to common questions, like a guidebook for your deep learning journey.
This whole deep dive has been amazing, from building simple image classifiers to deploying them in the cloud, running them in browsers and on our phones, even simulating self-driving cars.
Deep learning is so much more than just a theory. It's a powerful tool that's already changing the world.
It really is mind-blowing to see what people are doing with this technology. Who knows what the future holds? Thank you for joining us on this deep dive into practical deep learning. Keep exploring, keep learning, and keep pushing the boundaries of what's possible.